Hi, welcome to video 4.1D. Now we're going to apply integration to motion. So if you remember, okay, there's vertical motion, there's horizontal motion. Before, we were given the position function, and from the position function we could differentiate to find the velocity function, and from the velocity function we could differentiate to find the acceleration function. Well, now we're going to be working backwards. Since we know that the derivative of the velocity function is the acceleration function, then the antiderivative of the acceleration is equal to the velocity. So we're just working backwards. Now, on planet Earth, the acceleration due to gravity in meters per second squared is negative 9.8 meters per second squared, and in feet per second squared, it is negative 32 feet per second squared. In physics, you would call this constant g, but we're going to call it a for acceleration because we might not always be on Earth. We might travel to the moon and Mars and Jupiter, etc. All right, so since the velocity is the antiderivative of the acceleration function, then if you are on Earth, and let's say we do it in feet, then the acceleration is negative 32. Well, what happens then is you're going to integrate negative 32 dt. You're going to get negative 32t plus a constant. However, we're going to name that constant initial velocity because when the time is 0, if you were to take this equation and replace t by 0, you'd get negative 32 times 0 plus whatever that constant is. So as it turns out, that constant is the velocity at time 0, so we call it v0. Now, to get the position function, we're going to integrate the velocity function. So we're going to take the integral of our negative 32t plus v0 dt, keeping in mind that v0 is a constant. When I integrate that, I'm going to have negative 32 times t squared over 2 plus v0 times t, because this is a constant, so if it was 7, it would be 7t, plus another arbitrary constant, and that constant is going to be S0. And the reason we're going to call that constant S0 is because at time equals 0, we would have negative 32 times 0 squared over 2, which would be 0. We would have plus whatever the constant v0 is times 0, which would be 0. And then we would have this constant c1. Well, that constant c1, of course, is what is equal to the position at time 0, which we call S0. If I just reduce the 32 halves, you now have the formula that the book and I used to give you. We would tell you the position function is negative 16t squared plus v0t plus S0 if you're dealing with feet and seconds. And if you remember, I explained to you at the time that the 16 is half of the 32, and the negative 32 is the acceleration due to gravity on Earth. So as long as you're on Earth, vertical motion, your position will be negative 16t squared plus v0t plus S0. Okay, so here is number 74. A balloon rising vertically with a velocity of 16 feet per second releases a sandbag at the instant it is 64 feet above the ground. How many seconds after its release will the bag strike the ground, and at what velocity will it hit the ground? So, first of all, we start with this is a vertical motion, so we know, and we're on planet Earth because they didn't tell us we weren't, so we know the formula. You can derive this formula each time, but it's just easier to memorize it. Now, what we have is that position is really height, so we can call it h of t or s of t. They told us that the balloon is rising with a velocity of 16 feet per second. So there's our initial velocity, and we're talking about the moment at which it is 64 feet above the ground, which is the height at that moment in time. Okay, how many seconds will it, after its release, will it strike the ground? Now, the thing that you need to understand is what do we mean by strike the ground? It strikes the ground means its position, its height is 0. Not its velocity. Remember the stapler heading towards your head. So when you see it hits the ground, that means the height, or s of t, the position is 0. So we're going to take this expression, set it equal to 0. I'm not going to show you how to solve a quadratic equation. You'll get 1 plus or minus root 17 over 2. Of course, it can't be negative time. And if you had a calculator, you'd be able to evaluate 1 plus root 17 over 2 is 2.562 seconds. So that's how many seconds it'll take for that bag to hit the ground. The second question is, at what velocity will it hit the ground? Now, we know that the position function is this, so we know the velocity is the derivative of the position function, therefore negative 32t plus 16. So there's our velocity function. And we know that it hits the ground after 2.562 seconds, so you simply replace the t by 2.562 seconds, and you will get that it hits the ground with a velocity of negative 65.970 feet per second. Here's number 84. A particle initially at rest moves along the x-axis, so instead of calling the position s of t, we call it x of t, such that its acceleration at time t greater than 0, so keep in mind our t's are all going to be positive, is given by a of t equals cosine of t. So this is now a horizontal movement. This has nothing to do with acceleration due to gravity. This is not vertical movement. It's moving along the x-axis. Then they give you another piece of information. At the time t equals 0, its position is x equals 3. So when you get the position function x of t, this is telling you that x of 0 is equal to 3. The question is to find the velocity and position functions for this particle and find the values of t for which the particle is at rest. So again, since we know that the velocity is the derivative of the position function is the integral or antiderivative of the velocity. And since we know that the acceleration is the derivative of the velocity, then the velocity is the antiderivative of the acceleration. So we're given a of t equals cosine t. You're told that it begins at rest, okay? Initially at rest. You got to really be careful and pay attention to what they're saying. And they are saying, whoa, that's like way too thick. Okay, undo. Try it again. And we'll make it way thinner. And I like the purple, so we'll make it purple. And it is initially at rest. Okay? So, initially at rest means at time t equals 0, which is what initially means. At rest means it's not moving, which means its velocity is 0. So by saying it begins at rest, they're telling you that v0 is 0. In other words, when t equals 0, v is 0. So that's a piece of information we're going to use. It also told us that the time was always positive, and it also said at t equals 0, x is equal to 3. So first question is find the velocity and position functions. Remember, we were given the acceleration, so we're going to find the velocity by taking the antiderivative of the acceleration. Again, remember that the acceleration is the derivative of the velocity, so the velocity is the antiderivative of the acceleration. Now, they gave you the acceleration as cosine t dt. When you integrate cosine t dt, you get sine t plus c1, we'll call it, but really that c1 let's find out what happens. It says the initial, remember it was initially at rest, so v of 0 equals 0. So if I replace t by 0, I'm supposed to get that v of 0 is 0. And of course the sine of 0 is 0, and we do find out that c1 is 0. So we now know that our velocity function is just sine of t plus 0, or just sine of t. Now they also wanted the position function. So to get the position function, since the derivative of the position function is the velocity function, then the position function is the antiderivative of the, did I do that right? Yes, of the velocity function. So we're going to integrate our newly found velocity function sine t dt. The integral of sine t is negative cos t, again plus an initial constant, but remember that's why they gave you that information, that when t is 0, or the way they worded it, what I actually said, at t equals 0, its position is 3. They could have said its initial position is 3. Initial means at time t equals 0. So it's saying when I replace this t by 0, my v should be equal to 0 as well. And then I solve that. Aren't we lucky? C1 is equal to, At t equals 0, x is the position is 3, so I replace the position by 3. I replace t by 0. Cosine of 0 is -1, and your C2 will end up equaling 4. So the equation replacing C2 by 4 is that's your position function. Question then asks to find out the values of t when the particle is at rest. The particle is at rest when the velocity is 0. We found out that the velocity function was sine of t, so sine of t equals 0. And of course, the sine of an angle will only equal 0 if that angle's on the x-axis. Now, that would normally be when t is 0, plus or minus pi, plus or minus 2 pi. We can certainly replace that by k pi, where k is any positive integer, because remember they said that the time was positive.